Okay, this tutorial is covering a couple of topics regarding measurement. The first topic is how to count significant figures, or what we call sig figs. And then kind of like why we even do sig figs. And it's the reason why is because of you're limited, kind of like when you're measuring something, then you're limited by how many numbers you can go to, depending on what instrument you're using. So we'll go more into like the, I guess, philosophy of it in a couple of minutes. So the first thing to do is to learn how to count sig figs correctly. And what I like to use is something called the Atlantic Pacific rule to help count sig figs. And we say Atlantic Pacific rule because the Atlantic starts with an A, and the A means absent. So if the decimal point is absent, then you start counting digits, the first non-zero from the Atlantic side of the number. And if a decimal point is present, you start counting the first non-zero from the Pacific side of the number. Okay, so let's just look at a couple examples. So you count, there's really one rule for sig figs. You count the first non-zero and everything after. Including any subsequent zeros that come after the first non-zero. So, which is better if we look at a couple examples. So here's a bad drawing of the United States. Here's the Pacific side. Here's the Atlantic side. And that kind of is a mnemonic to help you remember like what side, the left or right side, to start counting numbers. So let's look at a couple examples. So the number 12. So just kind of ask yourself, do you see a decimal point? Is the decimal point present? No, the decimal point is absent. So you begin counting from the Atlantic side, and you count the first non-zero. So this is not a zero, so it counts. So the first non-zero and everything after counts. So this number has 1, 2. So this number has 2 sig figs. Okay, or I write 2 SFS, 2 sig figs. So let's try a couple more examples. So this number 1098, decimal point is absent. So you count again from this side. This is not a zero, so this counts, the first non-zero and everything after. So this counts 1, 2, 3, and 4. So this number has 4 sig figs. Okay, here's this number. Decimal point is again absent, so you start counting from this side. This is not a zero, so this counts and everything after. So 1, 2, 3, 4. So this number also has 4 sig figs. Okay, so let's try a number that's in scientific notation. On this number, we see a decimal point. It's right there, so you start counting from the Pacific side. And this is not a zero, it's a 2. So this counts. So you just take this bullet point completely literal. So this is not zero and everything after. So this counts and everything after. So this has 1, 2, 3, 4. And I like to just kind of like disregard that. I don't even really count that as when I'm determining sig figs. So this number has 1, 2, 3, 4 going from the Pacific side since the decimal point is present. So this has 4 sig figs. Let's try another number. Let's change it up a little, add some zeros. Okay, decimal point is present, so we count from this side, and you count the first non-zero. So all these are zeros, so they don't count. So this is the first number that counts, 1, and then everything after 1, 2, 3. This has 3 sig figs. Try some more examples. This one, decimal point's present. Okay, so decimal point's present. So all of these count. 1, 2, 3. 3 sig figs. Okay, this one no decimal point, so we count Atlantic side, and this is a 0, so it doesn't count. None of these count. Okay, only this one counts. So this number actually only has 1 sig fig. Okay. Decimal point's present, so we count from this side of the number. So just start way over here, Pacific Ocean, and then you count. I lost my spot here. Decimal point's present, so you count over here. This number has 1, 2. They actually all count since it's not a 0. 1, 2, 3, 4, 5, 6, 7. So this number has 7 sig figs. Okay, so I'll leave this up for a couple, so you could probably pause the video. So try doing these, for example. Okay, it's so you could pause the video and then try doing these using the Atlantic Pacific rule, and then we'll go over your work tomorrow in class. What you have here for this question. Okay, now more into like why we count sig figs. Okay, so it's because when you're measuring something. So if you've ever flown in an airplane and you finally get to cruising altitude, and you can unbuckle and use the restroom if you need to. Well, the captain of the airplane, they don't know exactly. It's not an exact measurement how high you're flying. They say 30. We are now at 30,000 feet. Okay, they don't know if it's 30. They don't know if it's 35,123 feet in the air. They don't know this number. They don't know this number. They don't know this number. They might not even know this number. So they just say they're around 30,000. It's an estimation. What number are they sure of? None of these. Okay, so we say that these are uncertain digits, and we say that the captain's only reporting the number to one significant figure. So that's kind of like the philosophy behind why we do sig figs. It's all relative to measurement and estimation. Okay, so here's a couple examples if you're measuring using a beaker or graduated cylinder. There are some rules for how to where to cut your number off when you're measuring. Okay, so when you're reading from glassware, always estimate the last. You're always estimating the last digit, so you're never certain of the last digit. And it depends what glassware it is. So I'm using different instruments here. This one is medium size. This one's the skinniest one, so you're gonna have the most sig figs on this one. And then this one is the least accurate tool. This one, actually, the correct word is precise. It's the least precise. So here's the key point here: is you always when you're using glassware, you always include one more digit than what the glassware is showing. So let's take a look at some examples here. So let's say you filled this up with water, and then you'll see what's called a meniscus, which is kind of like the glass is hydrophilic, so water kind of sticks to the sides, and then the middle part of the water sort of hangs down and creates this spot right here. So this is where you want to take your reading. So you want to get eye level with the glassware and then try to read it from there. And so how would you report this number? So this is each one of these going up by 1. So this must be 1.5, and this must be 2.5, 3.5, and then this must be 4.5 here. But we are not at 4.5. We're a little bit less than that. This would probably be maybe 4.25 or 4.3. Okay, and we're a little bit above that, so we're probably at, this might be 4.4. Okay, and so this is what we're kind of exercising this bullet point here. It says one more digit than what the glassware is showing. So this is showing whole numbers only. So we could go one more digit past that. Okay, we can't really say it's 4.41. I mean, we can't even really say that. The only number that we're sure of is this number, and then the last number is what we say is uncertain. Okay. Okay, let's try another example. So let's say we have water up to here, and here's our meniscus. So this is 1, from here to here is 1. So this must be 10.5, and these must be going up by 0.1, 10.1, 10.2, 10.3. So you figure out the hash marks, 10.5, 10.6, this is 10.7. So this is somewhere, and again, you could go one more digit than what the glassware is showing. So this glassware is showing the tenths. So you could go to one more digit, you could go to the hundredths, and that would be our uncertain number. Okay, so you could go to, this is probably 10, I would say 10.67. It's a little bit, so here would be 10.65, and it would be a little bit past that, so 10.67. And if you had another student measure this, someone else might say, oh, it looks like 10.66. So that's why we say that that number is uncertain, that last number. And then this is the one bullet, no matter what glassware it is, you could apply this to whatever it is. And this is probably the worst, a beaker. This is why we don't use beakers, because they're imprecise. They only go to like the tens place. So let's say water was filled up to here, and we know it's at least 20, but here's 25. But we kind of have to end there, so we could report the you could report the tens place and the ones place. But you can't go past that. You can't go into the tenths. So this would probably be like 20, I would say 23. It doesn't say what unit these are, but let's say they're all milliliters. So let's say this is 23. But we can't say 23.1, so, or anything like that. And then this number is our uncertain number. Okay, so here's an example of using sig figs in a math problem. So let's say you had to add all of these numbers together, like this volume plus this volume plus this volume. So let's say you had to add those together. Well, how many significant figures would you report that number? So the theory is that your final answer when you're adding can only be as significant as the least trustworthy answer. That means this is the most uncertain because this is the least precise instrument. So let's take a look and see what that means. Here's a couple. There's actually two different rules for adding and subtracting. So if you're adding and subtracting, you go by decimal places. Okay, so like on our previous example here, you actually don't use sig figs on this. You actually use the number of decimal places if you had to add these three numbers together. So let's see, you had to add these numbers together. This is an old example. So kind of forget the Atlantic Pacific rule for now. That actually only works for multiplying and dividing. So, but for adding and subtracting, if we're going to add these three numbers, you type them into your calculator and then you'll get this answer, 102.62315. And you count how many decimal places. This one has 3, this number has 4, this number has 5. So your final answer will have the least number of decimals as the lowest number that went into it. So it would be this number. So you count 3 decimal places, 1, 2, 3, and then you round it on this number. Okay, and then you use rounding rules. So if it's 5 or more, then you round this number up. Okay, so this is less than 5, so this number stays the same. So your answer for this would be 102.6. 102.62, and that would be your answer to, actually 3 decimal places. Okay, so you're using decimal places if you're adding and subtracting. If you're multiplying and dividing, you're going by sig figs. So here's an example. So if we multiply these numbers, so don't worry about sig figs just yet, just punch this all in your calculator and then you write out your answer, 2.26352, and you count sig figs. So here we have a decimal present. This has 3 sig figs. This one doesn't count, but these do, so this also has 3. This has no decimal, so you count this way, and they all count. This also has 3. So your final answer should be the least of any of these that went into it. They're all 3, so your final answer should have 3 sig figs. Decimal point is present, so this counts. 1, 2, 3. This is your 3rd sig fig, that's 6 there. Okay, use the number after it, this 3 here, and it's less than 5, so this number would stay the same, so 2.26, and that's your answer. Okay. Oh, actually, I had this was divided by a number. So I didn't catch that part, but luckily that also has 3 sig figs. So look at all the numbers that went into it. There's 4 numbers that went into this getting this answer, and they all have 3 sig figs. So your final answer, 3 sig figs. So take a look at the operation of math. If it's adding and subtracting, you go by decimal places, and if it's multiplying, dividing, you go by sig figs. Okay, if you have adding, subtracting, and multiplying, dividing in the same problem, you actually have to round. Before you have to actually round on the intermediate step. Okay, so this is step 1, is to do the parentheses to do this part. So if we do this, you notice you're adding and subtracting here, so you use the decimal rule. Okay, so if you do this operation right here, you get this number. Because you have to be careful, you can't just load this whole thing up in your calculator, because you have to actually round this number before doing this operation. So now this number got rounded, okay, to 3 decimal places. Actually, it hasn't been rounded yet. So the lowest number of decimal places is 1 because of this number. So that's why you only have 1 right here. 1 decimal place. Okay. And now, once you applied this rule, now you're just dividing, and now you actually apply the multiply divide rule. So you go by sig figs. The common mistake I see is students will load this whole thing up and then they'll just go by sig figs. So you actually have to do this as like a whole separate step. So, and then you actually have to like kind of write this number out and then apply the separate rule separately. So it's kind of mechanical, but that's the right way to do it. Okay, and then this is your final answer. So this number has 4 sig figs because this number has 4. This one has 5, so this one has less. So this is your final answer. Okay, our last topic here is precision and accuracy. So precision means the data is reproducible. Okay, it may or may not be accurate, also be accurate, but precision means the data is reproducible. So that means like if you use this dartboard analogy, this has actually high precision, but you have low accuracy. Accuracy is like hitting the bullseye. Okay, so precision means you're bad, but you're really bad repeatedly, like repeatedly bad. So you hit the same bad spot. I'll give you a science example after this. Okay, precision, another thing about precision is it's limited by your equipment. So if you remember the beaker example, beaker versus a graduated cylinder, we would say a beaker is imprecise, and we would say a graduated cylinder is more precise, but we don't really know if it's accurate. So more decimal places means better precision. If your glassware goes to more decimal places. Okay, and then a burette would be are typically even more, because well, the ones we use in class are going to go to the 100th place, and these might go to the 10th. Okay, so what is accuracy? Accuracy is how close you are to the true known value, accepted value. So this picture right here is repeatable, so this is precise, and they've hit the true mark, so it's accurate. Okay, and it can also be it can actually be calculated by calculating a percent error. So, and then this is the formula. So let me give you a quick example on precision and accuracy. So let's say you have a scale. Okay, here's the number readout. And let's say you weigh, there's like a weight here, and this has been machined by lasers and really accurate equipment to weigh exactly 10.0 grams. Okay, so this is kind of like the take-home question. So let's say we weighed this 3 times. Okay, and then you get the following, the following data. So let's say we weigh it 3 times, and you get first trial, and it says it's 9.9 grams. And let's say on the second trial, you get 10.0 grams. And then on the third trial, let's say it weighs 10.0 grams. Okay, so answer the following question. So is this data, and again, this is machined, and let's say it costs a lot of money. It's made with lasers to be exactly this number. Okay, so here's the following data. Is this data precise or accurate?
Attention staff, if you have not taken your photo ID,
or both?
Here, do so now.
Explain.
If you have not taken your photo ID picture, please do so now at the theater.